Because you can take that. So it's the right
No.
answer is 7.5 instead of 7.5.
I've had students do that before because they might have remembered doing it in class, and they have that kind of memory, but they don't have any way to do it. Might give them a point on a 10-point problem or something.
Just a point.
Nah.
But you didn't do it.
Okay, so we have 3 weeks of classes left and then finals. So I just want to kind of go over. We only have 2 sections left to cover though. So we'll cover 10.5 today. We might need a little bit more time on Wednesday, just depending on how many questions you guys have on volume. 10.6, we'll have 2 days also for 10.6. That's the right triangle trigonometry. So we have sine, cosine, tangent, things like that. Setting up these triangles, knowing what the definition of sine, cosine, and tangent are, and then applying them. So we might take 2 days for that, and then we have a day for the review, and then we'll have test 4. So test 4 will cover chapter 10 material. After you guys take test 4, this next week is all review. So we'll come in and review test 1, test 2, test 3, and test 4. Give you back test 4, give you your input on that. Review. OTC doesn't have classes the last Friday, Thursday or Friday. They call that, no, I guess they do have them on Thursday. They don't have them on Friday. It's your study day. So for you guys to look for tutoring or extra support. Your final for the class is set to be Wednesday of finals week from 11 to 12:50 in this classroom. And some of the students had, come to me with concerns about whether that's going to fit in their schedule, or they might have 3 classes finals on Wednesday. So I do have another time where I am giving another final on Monday of finals week from 2 to 3:50. And I'm willing to let a few of you switch over there. I can't have everyone because I have a limited space. I'm giving a college algebra final, and I have about 15 students that will take the college algebra final. So I can work out. If you want to do that, you need to send me an email and let me know, so then I don't overbook that space. So it might come to a time where I have to start turning people away. So if you want to do that, let me know as soon as possible there. But otherwise, the final will be in here from 11 to 12:50. Does anyone have any questions over chapter 10 material of what we've covered so far? Covered 10.1, 10.2, 10.3, and 10.4. We started out with points, lines, angles, a lot of definitions. What's a triangle? What kind of triangle? Right triangle, obtuse triangle. Question?
Yeah, I was on the homework.
Mm-hmm.
I was doing 10.1, and I have no idea on number 33 how they figure.
So we must have talked about this at some point in time in class. So the instructions for 27 through 34 was to find the complement of each angle.
Which means that they have to add up to 90, right? Okay.
Yes. So here you're looking for the complement of an angle, and it's going to be a function of x, because you don't know what x is. So you set this angle, x plus 10. That's for any given x, it would be, if x was 0, the angle would be 10. If x was 10, the angle would be 20. But x is just a placeholder for a variable. So the angle measurement is x plus 10. If you add y to that, y being some other angle measurement, set that equal to 90, you're going to come up with, knowing they're complementary, so you have x plus y is 90, but we don't have x, we have x plus 10. So solving for y, we get y equals 80 minus x, which should make sense. If this is x plus 10, then the complement is going to be 80 minus x, because that 10, it would be 90 minus x, but it's x plus 10 instead of just x, right? If I want to solve for y here, it would be 90 minus x. 90 minus angle you're given gives you your complement. Here, instead of be given an angle, you're given an expression, which is x plus 10. So that'd be 80 minus x. Does that make sense?
Yeah.
So if it was x plus 20, then this would be 70 minus x.
Right.
Right? 70 and 20 would be 90.
Okay. That makes
make
sense.
sense?
Now. Yeah.
Any other questions on the homework? These concepts are pretty straightforward. It's just sometimes the application of them mixed in with the algebra, so don't let yourself get too caught up on that. So today we're going to continue on and look at three-dimensional shapes. So we've only looked at 2 dimensions so far. We've only looked at a flat plane. Talked about the x and the y components, or we can talk about length and width, various different dimensions, but we've only talked about length and area. So today we're going to talk about volume, and then on top of volume we have surface area. So we only have 2 objectives: to find the volume and surface area of solid figures. Solid figures would mean they're 3 dimensions. They have to be 3 dimensions. You can't talk about the volume of a rectangle. So you have to have a 3-dimensional shape for that. Polyhedrons is a 3-dimensional figure bounded on all sides by polygons. The simplest polyhedra are rectangular solids and cubes, which are bound on all sides by rectangles or squares. You can think of like a dice, any kind of dice you roll if you have a 6-sided dice, a cube. Here's an example of a rectangular solid as shown. Again, you want to make sure your units, inch, inch, inch. So these units are the same. You cannot multiply inches by feet. You have to make sure you have the same unit measurement. So a lot of times when you start introducing this idea of a solid or introducing the idea of volume, we talk about how many cubes would fit in the shape. So if this is 3 inches by 2 inches, then 3 by 2 cubes would fit, and then 1 inch by 1 inch, so this is 2 inches tall, 2 by 3 cubes would fit. So if you take apart all these cubes, and each cube's 1 inch by 1 inch by 1 inch, then you get cubic inches. So here, this shape is 12 cubic inches. The volume can be obtained by multiplying length, width, and height. 3 inches by 2 inches by 2 inches, giving us our first volume formula. If we have a cube, all side lengths are the same, so it's s times s times s, which we could write that as s cubed. If we don't have a cube, if they're all different lengths, the formula still holds length, width, and height, so it's just different numbers, length times width times height. Our units will be something cubed. So let's look at our first example. Find the volume of the rectangular solid picture. What is this volume going to be? Be careful. I need to change everything to inches, or I need to change everything to feet. Since these are already in feet, we would probably need to straightforward to take 30 inches into feet. Okay. If I change it all into inches, our numbers are going to be really large. And then we could convert it into feet cubed.
But 30 inches is not.
It'll be a fraction, right? And that's fine. So our first step here is to write inches into feet, and we can leave it as a fraction. Since there are 12 inches in 1 foot, to get rid of inches, I put the 12 on bottom. So this would be 30 over 12 feet. Is the same thing as saying 30 inches, which is 2.5 feet. Now it's knowing the formula and hitting the right sequence of buttons in your calculator. We use the formula, which is length times width times height. 11 times 4 times 2.5, and we get 110 feet cubed. You guys have all done this before, right? Might have been maybe 10 plus years ago, but hopefully it comes back. Of course, this section likes word problems. And word problems is just being able to draw the geometric figure and then apply the formula and hit the right sequence of buttons in your calculator. So we might want to know how much chlorine to use in a swimming pool. The pool is rectangular, 18 feet wide, 36 feet long, and has an average depth of 4 feet. So we can say, it doesn't really matter here. We draw this swimming pool, 30 feet, 36 feet by 18 feet by 4 feet. And it wants to know how many gallons does it hold. And here, I wouldn't expect you to memorize how many feet cubed are in a gallon. So it gives you that. So the first thing we need to find is how many feet cubed makes up a swimming pool. That would be our volume. And then we convert our volume measurement to a gallons measurement. So there's 7.48 gallons for every 1 foot cube you have. So if you have a bucket that's 1 foot by 1 foot by 1 foot, that's going to hold 7.48 gallons. So the math here, what's 36 times 18 times 4?
2,592.
And that would be in feet cubed. So now our next approach is convert that from feet cubed to gallons. So I have 2,592 feet cubed. I put where I want to go. I want gallons. So I want to get rid of feet cubed. I put that in the denominator. When I put it in the denominator, when I multiply the two units, they cancel. This is my setup. I know there are 7.48 gallons for every 1 foot cubed. So that tells me I'm going to multiply this number times this number, and what do I get? So then I read on the chlorine bottle that says how many cups I put in it for every 19,000 gallons. I have 19,000 gallons of water, so I need to find out how many cups I need to add to that for my swimming pool. So here's our conversion factor there. Capacity of the pool is about 19,388 gallons. You guys see that? First step is to find the volume in the units given, and the second step is then to convert it into what it wants. It wanted to know how many gallons we needed. Any weird conversion units you need to know for problems will be given to you just like this one was. So the volume formula of any shape can be found by taking the area of the base times the height, right? If I take the area of the base and multiply that by the height, I can get the volume. So if we look at a cylinder, sometimes students try to memorize the formula for cylinder, but if you think of, you know the area of a circle, right? Pi r squared, then you take that times the height. The area of the base times the height is the volume of a cylinder. A right circular cylinder, which would be given here. The area of the base, pi r squared. Pi r squared. And then if I take that times the height, I get volume. Any shape I can do that. Area of the base times the height. So you can memorize that formula, or you can just remember area of the base times the height. And the area of the base is pi r squared. So it leads us to our next example here. How many cubic inches does a soup can hold if it is a right circular cylinder with a height of 4 inches and a radius of 1.5 inches. So pictures are helpful here. If I say I have a right circular cylinder, or I have a soup can, right? And it doesn't have to be anything too beautiful. 4 inches, and the radius here is 1.5 inches. Important thing when we do right circular cylinders, know the difference in diameter and radius. Because it could have also said the diameter is 3 inches, and you would need to calculate the radius before you plug it in the formula. So volume is area of the base times the height. Area of the base would be pi 1.5 squared times the height would be 4. So doing that, we get 28.3 inches cubed.
So are three-dimensional shapes always going to be cubed?
If they want volume.
Okay.
So the next thing we're going to talk about is surface area. So we might say, how much aluminum do I need to make this can? And that's just going to be the surface area. So that's going to be units squared.
Okay.
If it says volume, it's going to be cubed. Now you can convert units cubed into things like liters, gallons, fluid ounces. So there are certain measurements for volume that aren't cubed, but there's a conversion factor for that.
And you said that on the test that you'll put these conversion factors.
If there's anything, you should know there's 12 inches in a foot. You
Yeah.
should know there's, 3 feet in a yard.
I guess.
But if there's anything outside of that, I'll tell you 5,280 miles or feet in a mile. And I'll tell you anything weird like the gallons or liters or anything like that. I'll give that to you.
And then you'll also give us the formulas.
The formulas that will be given will be the same ones that Mojia gives you. So I'll give you that formula page from Mojia, and some of those are on there. And I have that posted on Blackboard. And I'll probably give you guys that printout when I give you the pretest, so you can know, and then I'll give it to you again on the actual test.
Thank you.
Yes.
On the one that,
Mm-hmm.
yeah, how did you come up with 28.3?
What's 1.5 squared times 4 times pi? Pi being 3.14.
Right circular cylinder?
Mm-hmm.
I don't know what that means.
A right circular cylinder is where the base here, this is 90 degrees. You could have a circular cylinder that's skewed,
Okay.
and we won't talk about those.
Okay.
But the volume is going to be different on that, and it's a little harder to calculate. But we will, anytime it says a circular cylinder, it will say a right circular cylinder.
Would you have to incorporate angle?
Huh?
Would you have to incorporate angle in that sense?
Yes, you have to find the instead of the height, lattice height of it. There's a formula for it, but we won't go into that. We do basic geometric shapes here.
I like basic.
The next more popular type of geometric shape are pyramids, and the bases can change. But the volume for a pyramid is going to be 1/3 base times height. So very similar to area of the base times the height, but anytime you have a pyramid, and a pyramid is when you have a base that all goes to one vertex or one point, right? So you can have a pyramid with a circular base, you can have a pyramid with a triangular base, any kind of shape as your base, and it can be a pyramid. And the formula for that is 1/3 base times height, right? So here we're looking for the volume of the Great Pyramid of Giza. It has a square base. So we have a square base, so that tells us that the length and width is the same. So we have some point in space here. We have 230.6 meters and a height So if we can visualize this, this is 230.6 by 230.6 and a height of 138.8 meters. So the volume formula is 1/3 area of the base, which is 230.6 times 230.6 times the height, which is 138.8. This is just going to be a huge number. This should say meters cubed, not squared.
Why did you take 2 over 230?
This, because it's a square, so I take length times width. So 230 is it tells you it's the square base, so it only has to give you one measurement. For length and width, it's the same.
So you do it twice.
Yes, or you can push in squared. You could write this as 1/3 230.6 squared times 138.8. This would be this is the area of the base, and this is the height. The base is square, so the area would be squared. Length times width. So plugging that in your calculator, it would be 2,460,293 meters cubed, not squared, because we're talking about volume. Meters times meters times meters is meters cubed. You guys getting the same answer as that with your calculators?
My calculator won't take a number that big.
Really?
Yeah.
Let's see what your settings are on.
Look at the.
Is it go to scientific notation? So it does take a number that big. It's just in scientific notation.
Okay.
The e to the 6 means you move the decimal 6 places to the left
Okay.
or right, depending on if the 6 is positive or negative.
Okay.
So it's positive, you move the decimal to the right, 6 units. You could probably change your output to not go to scientific notation when they're that big, but. Here's a right circular cone. So this is kind of like a pyramid. The base is circular though. So we call those cones. We did the area of the base. We get pi r squared, right? Times the height here. The height would be given here. This is what's called S, is called the slant height. You have to be very careful what you're given. If you're given the slant height, you have to calculate the height. A lot of times it's not given to you, and you have to calculate it by using Pythagorean theorem. So the volume formula still works here. 1/3 area of the base, but the area of the base is pi r squared, right? It's the same formula, 1/3 base times height. Here though, the height is h, not s, not the slant height. So sometimes the figure will give you the slant height. The first thing you have to do is calculate the height by using Pythagorean theorem. Then you have the h value to plug into your volume formula. So here we're looking at water cooler cups at a golf course. It's a right circular cone with radius 1.5 inches and a height of 3 inches. So we have a right circular cone. It doesn't matter the way we draw it. We draw it up or down. Our radius is 1.5. Be careful if they give you diameter. And the height here is given as 3 inches. So then it also tells you the conversion from inches cubed to ounces. So the first thing we have to calculate is inches cubed. So the volume is pi r squared times h. which is pi times 1.5 squared times 3, which gives us 7.1 inches cubed. Then we do that conversion. We want to go to ounces. Let me go
So we
ahead.
don't do the 1/3 then?
Oh, I didn't put in the 1/3. Thank you. Yes, you do need the 1/3.
I was just.
Yes, volume is 1/3. Volume is 1/3. So we get 7.1 inches cubed. So then I want to convert that 7.1 inches cubed. I want to go to ounces. I want to get rid of inches cubed, so I put that in the denominator. So when I multiply these numbers, the inches cubed cancel. And it tells me 1.8 inches cubed for every 1 ounce, which is a little bit different than the other conversion, right? It gave us how many gallons were in 1 cubic inch.
Yeah.
Here it says that for every 1.8 inches cubed, it's 1 ounce. So do you guys see the 1.8 goes with the inches cubed? And I put that in the denominator because I want to get rid of the inches cubed that's in the numerator. That's probably the common mistake. Students don't know when to multiply and when to divide by the conversion factor. It depends on how they word it, how they give it to you, right? I could say there are 12 inches in a foot, or I could say there's a 12th, I could say there's a 12th of a foot in an inch, right? So along the same lines, you want to make sure you pair up the right number next to either inches cubed, or if it's gallons, put that number by the gallons if you want to go to from feet cubed. And you always put the unit you want on top and the unit you want to get rid of on bottom, and then the corresponding number beside it. So here we're going to actually take inches cubed and divide by 1.8 to get our answer. So it turns out these cups hold 3.9 ounces. Which means a little more than it holds 7.1 inches cubed, right? Typically we think of things in ounces. 12 fluid ounces. We have an idea what that means. Gallons, liters. We can visualize 2 liters, or 2 gallons of milk, or a liter pop bottle, or 12 ounces of soda, right? You guys, those are more mean more to you than inches cubed or feet cubed. So the last volume formula we're going to talk about is a sphere, right? So just like a circle is a set of points equal distance from a center in 2 dimensions, a sphere is a set of points equal distance from a fixed point, but in 3 dimensions. Very similar to, that 1/3 for a pyramid or a cone. For volume of a sphere, we have 4/3 pi r cubed. We have to have the cube for volume. We have to be multiplying our units 3 times to get volume. So it's 4/3 pi r cubed.
But it's telling us the diameter, so we need to take it back to the radius.
Yeah, so on this example here, it gives us diameter. So the only thing you need to know for volume of a cube is the radius. There's only one unit of measurement that defines a sphere. So here, if I have a sphere, this is given diameter is 164 feet, but I don't want diameter for my formula. 4/3 pi r cubed. For my formula, I want radius. So what's the radius here? 82 feet. So if I plug that into my formula, I have 4/3, 3.14, 82 cubed. I get a huge number again. 2,309,665 feet cubed.
wonder how big the volume of the earth is then.
Yeah, it's just going to be another just ginormous number that we have no reference for anything about. You know, they always give you those numbers. You know.
Like this many earths will fit in this. And Jupiter.
Yeah. Have you? Yeah, you guys have probably seen like this is our sun. This is relative type things. It's just so massive. After a while, you get into such huge numbers, it doesn't mean anything because you can't even imagine it. So that kind of goes over all the examples of volume, but we're going to look at the exact same shapes and then look at their surface area. So surface area is the amount of area to make up the outside of their surface. Here's some formulas. Instead of memorizing them, you can just think of you're taking the area of each side. So if I have a cube, right? If I have a cube here, see if I can draw this decent. It's a little off. SSS, right? The surface area of the front side is S times S. The surface area of the back side is S times S. The left side, the right side, the top, and the bottom. So it would be 6S squared, right? Because there's 6 sides, and all their surface areas, or all their areas of those sides, are S times S. Rectangular solid, make it a little more, Here, I could have length, width, and height. So if I look at the bottom and the top would be length times height, or be length times width, right? L times W, top and bottom. 2LW, that gets rid of your top and bottom. Front and back would be L times H. L times H plus L times H, 2LH. And then left side and right side would be width and height, which gives you 2 width and height, right? So you don't have to memorize these formulas. You can think about it on your problem. If you draw a picture and say, I want the surface area, I'm going to find the area at the top, the area at the bottom, the area at the left, the right, the front, and the back, whatever the shape may be. Sometimes on surface area, we'll talk about open boxes. So you'll do bottom, left, right, front, back. So there's only 5 sides to think about. A right circular cylinder, again, right? The surface area here is 2 pi r squared. That's the area of the top and the area of the bottom, right? If I was to take a piece of paper and I would fold it over, I got a cone, or I have a right circular cylinder, right? Right? What would this distance represent of the circle? The perimeter of the circle, right? Right? So if I take, what would be the surface area of this piece of paper? Length times width, right? Folding it over, the length is the circumference, and then I have the height, right? So here, 2 pi r is the circumference of the circle times the height. So breaking this down, 2 pi r, that's the area of the top and the area of the bottom. Do you guys see that? Plus, if I was to take this can and open it up, the distance from one side to another side, that's going to be the circumference of the circle, and circumference is 2 pi r, then times the height. Again, you can memorize these formulas, or you can think about them and break it down. I need the area of the base. I need the area of the top. Now I need the area of the lateral sides. And then the last surface area we're going to look at is a sphere, and the formula is pi r squared. You should be able to convince yourself we're looking for area, so that the largest value should be squared, right? Squared from r times h. So my units are going to be squared. So unit times unit, squared, unit times unit, unit squared, squared. My units are going to be squared.
So on like number 7 where it asks you the answer, so it would be the answer inches squared.
Correct. Yeah, because our units are squared. We're looking for surface area. How many square inches? So that automatically tells you I'm looking for surface area or area of sheet metal are needed for the soup can in example 3. So that soup can in example 3, we had a right circular cylinder. Its height was 3 inches and its radius was 1.5 inches, right?
4 inches.
Oh, 4.
Yeah.
It was example 3. 4 inches. So I'm looking for surface area, and if I have pi r squared, that gives me the area of the top, and pi r squared is the area of the bottom. So 2 pi r squared plus 2 pi r h. 2 pi r is going to be the circumference of the circle times the height would give me the lateral surface area. Lateral surface area is kind of everything that's not the top or bottom. So plugging that in, I have 2 pi 1.5 squared plus 2 pi 1.5 times 4. Using 3.14 as pi, I get 51.8 inches squared.
I must have done it wrong because I got 51.
Did you plug in 3.14 for pi, or did you plug in something? And you got what?
51.93.
You got a larger number.
Didn't enter. I'll try it again.
Let's see.
Oh, I see where I messed it up. It's not anything.
Get
It was
2
my fault.
4 times 1.5 squared plus 0.14. Anyone else have an issue with that? Pretty straightforward. So let's look at again, these are our formulas we'll have. Volume of a sphere is given, and surface area of a sphere is given. Surface area of a right circular cylinder, and the volume of a circular cylinder. A right cylinder, sorry. They are circular cylinders. The surface area of a rectangular prism and the volume of a rectangular prism is given. So the only thing that I don't see on here would be the volume of a pyramid, which would be the 1/3 base times height, right? Or of a circular or of a cone, which is still 1/3 pi r squared times height. So those are the only two I see that you might be asked about. That's not given on the Mogia formula sheet for the math part of it. So we look at some of the homework problems, 7 through 39 odd. So find the volume of each figure. You should be able to do that without any issues. Oh, sorry,
No, you're
still in your notes. Again, the pyramids. The example I wanted to talk, see if it gave it. So your book gives you the height of all of these. I thought for one example it gave you the lateral height, but it doesn't here. So it gives you everything you need. You just need to know the formula and how to apply it. Oops. Pretty straightforward there. Some of the figures get a little more advanced where they might cut out some pieces, just like in the area formula, they might say a circle and then a square inside that and want to give you the area of the square or the area of the circle that's not the square. I don't know if you guys have had a chance to do some of those yet. You might have a shape that's like this, and they want the shaded region. So you take the area of the big circle minus the area of the square. Pretty straightforward approach if you haven't had a chance to do that on 10-4 yet. You get some shapes. Still on 10-5. You get some shapes like this, right? So if I want the area of the blue shaded region, I have to take the area of the larger square, or in this case, the area of the circle, minus the area of the triangle. Right? If I wanted this shape,
How does it tell you the area of the circle though?
well, area of the circles, pi r squared.
Okay.
So you have to find the radius and you have to break that down, right? So here you're getting that the diameter of the circle is 6, the radius is 3, right? So it gives you everything you need. It's not as simple, just find the area of a circle. It's find the area of a square, find the area of a circle, find the area of a triangle, and then add and subtract what you need to find the right shaded region. You're gonna do the exact same thing in the volume, the area of the larger volume minus the area of the smaller volume, right? So if I want to know what the volume is here of a right circular cylinder that has the center board out of it, I'm going to take the area of the bigger circle minus the area of the smaller circle, right? Same concept, you're just applying it to 3 dimensions. And then you're also asked to find the surface area of these given shapes. And those are the maybe more straightforward, the easier shapes with nothing cut out of them. So you're corresponding the surface area there. A lot of times I see students will try to force the formula 2LW plus 2HW, and then they'll say, if this is L, this is W, this is H. A lot of times they make mistakes because they just plug in the wrong thing at the wrong part. You're much better off to think, okay, what is the area of this side? What is the area of that side? What is the area of the top? What's the area of the bottom? What's the area of the right? What's the area of the left? And then add them all together instead of trying to force that formula. Oh, that's something else. So if you guys have any questions, I'll be able to answer them on Wednesday. If there's no questions on 10-5 on Wednesday, I'll probably go ahead and start 10-6 and see, kind of how far we're at and gauge. Whether on Friday it might just be a work day and I'll just be here and I can answer questions on 10-5 and 10-6. Or I can make it like an optional type day where I'll be here, but I won't have any necessarily new lecture. If we get that far. So we'll see how that ends up. All right, I'll see you guys on Wednesday.